Hello everybody. In this video, we're going to use a z-score chart to look at a specific observation and determine the percentage of values that could be above that observation and the percentage of observations that could be below that observation. Now, I'm assuming you know about the empirical rule. I'm assuming you know about normal distribution. I'm assuming you could get a mean and you can get a standard deviation. So let's look at the values here. In A, if we have a score of 65, and with this score of 65, we're assuming a standard deviation of 81, a mean of 81, and a standard deviation of 6.3. So that gives us, it is 2.54 on our chart, or on our curve. Now, if you look at a z-score chart, you can look this up, and you can get one online, and we can see when we intersect that number, we get 0.0055. What this is saying in English is this is the number of values that would be above this. So basically what we're saying here is a score of 65 is very, very low, and the odds of getting a score less than 65 are going to be about 5.5%. Certainly not very good odds there. So let's look at the second observation. The second observation, we have a score of 83. Again, the same mean of 81 with a standard deviation of 6.3. That gives us a z-score of 0.32. So 0.32 is just where it fits on our normal distribution curve. So if we could look up the z-score chart, we could look up the percentage of values that would fall above 83 and the number that would fall below. A little small here, and I've got my z-score chart out, and we get 0.3754. So that is basically saying that 37.45% of values will be above 83, and then subtract that would be below. So basically you get to see what the percentage of, and this number here is a percentage of values that would be above that. So basically we're looking at this and a score of 83 that there's 37.45 of the scores would be above that. We usually say when we look at these, like, what are the odds that a value is above 83, or what are the odds that, or the probability that our value is less than an 83. So not surprisingly, once we get a value that is really close to the center in our standard distribution, I mean, we get basically 50% could be above it, 50% could be below it. And the z-score is where that value fits on the curve, and that chart just gives us that percentage. So if we take C, a score of 93, okay, 93 is above our mean of 81, we could look on the z-chart, on the z-score chart, and say that it gives us a number of 0.0287, or only 2.87, only 2.87% of values would be above that. So indeed a very high score. So 93, again, with the standard deviation of 6.3, with a mean of 81, falls on 1.9 on our curve, which is our z-score. And if we look up the z-score chart, we see that only 2.87% of values can be above this. So certainly, again, a very high number. So if you take a look at these numbers, notice as they get larger, like 63, 83, and 93. And as these numbers get farther from our mean, our z-scores get smaller and smaller. And that makes sense, because what we do is with the z-score is we determine exactly where that observation fits in our curve, and that percentage gives us the percentage of values that could be above and below that. Again, this is with normal distribution. So let's look at D. D, we have a score of 100 and a mean of 81, standard deviation of 6.3. Look at this z-score on the chart, or the z-score chart, 0.0013. So we get a 0.13 probability of a score falling above this. So we're really kind of getting an outlier territory. So indeed a very high score. So most likely we're not going to get much scores above this. And if we do, the odds of that happening are very, very small. So what we can use, this kind of sum this up, is we could use z-scoring and a z-score chart to use descriptive statistics, which we've just used here to use descriptive mathematics to see where the z-score actually falls on the distribution curve. And then we could use predictive mathematics by looking at that z-score chart and determining the odds of the probability that we have scores above and below that number. Thank you for listening, and I bid you all a very well rest of the day. Thank you.